Good morning, everyone. My name is Vikas. I'm from MSM Institute of Technology, and today I'm going to give a demo of network intrusion and countermeasure selection. So, I'm going to explain the introductions to what network intrusion is, then what network intrusion detection is, then what is NICE and how is it different from the pre-existing technologies. Then I'm going to describe all the existing technologies which are already present in the market and the difference between those existing technologies with the NICE framework. Then we'll be going through the NICE framework in detail, and finally we'll go into the countermeasure selections. The countermeasure selections, like how we respond to the threat, which is network intrusion. Finally, I'll be concluding, and then we'll go into the references. In the end of the quiz, in the end of the video, we'll also see the links to quizzes that you can take for value addition to your courses. So, network intrusion detection and countermeasure selection, which is NICE. So, what is network intrusion? Network intrusion is any unauthorized activity or policy violations that happen or that is caused by an attacker. Network intrusion is very dangerous for any type of network because it can result in many malicious behavior. It also includes the policy violations, such as if you are having a policy of not doing something and you are doing something, and it is a case of network intrusion. There are various types of network intrusions, so we'll see a few of them. Eavesdropping. What is eavesdropping? Eavesdropping is basically when an unauthorized person listens to what you're communicating through your network. So the eavesdropper can use two type of technologies. One is snooping and one is snooping. In one, he'll only be listening to what you do, and in the other, he might modify some data. And the next type of network intrusion is data modification. Data modification, the intruder not only listens to what you're saying or not only captures what you're saying, he actually modifies the data that is being sent. So the data that is being sent from the receiver to the sender is different. Like, receiver is sending X, he is modifying it to Y, and the sender is receiving Y. So this can result in many discrepancies. So this is data modification. Then is the identity spoofing. What is identity spoofing? It's impersonification. Basically, I'm showing that I'm someone else. An unauthorized user is showing that he is an authorized user. So that is called identity spoofing. Password-based attack. Any attack that involves capturing your password and using your password to gain access to your system is known as password-based attack. This type of attack is the most common attack, because if you gain the access of anyone's password, then you gain the entire access of the system, and the system cannot even detect that whether you're an authorized user or an unauthorized user. Denial of service attack. Basically, all the services, all the attacks that we have seen so far, in all of those attacks, the unauthorized user will still have the access. Like, imagine that I am an unauthorized user, and you are an authorized user. So you will still have whatever access that you had, even if I have intruded your system. But in the denial of service attack, basically what is done is that the service is denied to the authorized user. So the unauthorized user is getting the access and he is making the service unavailable for the authorized user. This is known as the denial of service attack. The next is man-in-middle attack. If there is a person who is listening to or doing any changes between the receiver and the sender, then that attack is known as man-in-the-middle attack. Compromise key attack. So key. What is a key? A key is a value which is used to make ciphertext out of normal text. What is ciphertext? Ciphertext is the encrypted text or encryption mechanism through which the password is encrypted and sent. or the data is encrypted and sent. So the key is used to encrypt that data. There are many types of keys: additive ciphers, some substitution cipher, and many more. So for example, I'll give you of an additive cipher. So you want to send that uh, hello. So if you are using a key of 1, then what will happen is that the ASCII value of all the characters is taken, HELLO, and 1 will be added to all of them. So it, instead of HELLO, it will be sent IFMMP. So that is an example of additive ciphers. So that key, if I know that if I am an intruder and I know that your key value is 1, then I can easily decipher your text. So the entire concept of cipher will go waste if the key is revealed, because the key is the key of deciphering a cipher text. So the compromise key attack is the attack that tries to get your key. Sniffer attack. Sniffer attack is the attack that doesn't disturb your system. It lets your system go as it is going. It actually does not intrude in your system also. It just sniffs your system. Sniffs means that it can check that how much of the data is being sent, how much amount of data is being sent, what type of data is being sent, without actually gaining the access. And this attack is very, very difficult to track. Application layer attack. So application layer attack, the attack is not actually on the system. This attack is targeted to the users, the applicants, the persons who are using the system. For example, there's a website that someone has built and I am an intruder. I want to attack it on the application level. What I can do is I can bombard it with requests. I'll keep on bombarding it with requests until it denies the service. For example, that if it has a bandwidth, if it has the capability of handling 1,000 requests at one time, and if I bombard it with 10,000 requests, so obviously the server will go down, and an applicant who is trying to use that server will not be able to gain access, because I've already bombarded it with a capacity that is more than its original capacity. So this is known as the application layer attack, in which the target is not the system, the target is the users. So now we have seen what network intrusion is. We'll move now to network intrusion detection. An intrusion detection system is a device or software application that monitors network or system activities for malicious activities or policy violations. And if any of these are found, it generates an electronic report to a management station. That management station can be a person or can be a system. So it includes the following things. It includes monitoring and analyzing both user and system activities. So it not only monitors the activities of a user, it also monitors the activity of a system. The behavior pattern of the user and the system is compared to the behavior pattern of all the normal users, so that any unexpected behavior is tracked and reported. Analyzing system configurations and vulnerabilities. It analyzes the system configuration and the vulnerabilities of those configurations. It also includes things like assessing system ability. It has the ability to recognize patterns typically of attacks. As we have already seen, that it matches the pattern of a normal user with the new user, of all the normal users with the new user, and if there is a lot of change in the pattern, then that can be taken as an unauthorized or malicious user, using the abnormal activity patterns. And all the policies which are feed into the system are checked for the violation of policies. So IDS is the same thing, the intrusion detection system. So there are two types of IDS. One is the active IDS and one is the passive IDS. So what is active IDS? An intrusion detection system is also known as an intrusion prevention system. So in case of active IDS,
Uh, the IDS is configured to automatically block suspected attacks without any invention required by an operator. Intrusion detection and prevention system has the advantage of providing real-time corrective action in response to an attack in case of the active IDS. The passive IDS is a system that is configured to only monitor and analyze network traffic activity and alert an operator which is present with the system all the time, about these activities. So, whatever corrective measures has to be taken will be taken by the operator. So, this is the difference between active and passive. So, depending on your network type and your system type, you can choose any of these intrusion detection systems. Both have some advantages and some disadvantages. Whether on the active thing, you will have a corrective measures automatically generated. On the passive, you'll have an option to choose between the actual things that you want to block and the things that you want to allow. Now, we'll be moving on and seeing the existing systems that exist in the market currently for the intrusion detection. So, what are the existing systems that already exist in the market for this purpose? We'll see a few of them. The first one is Bot Hunter. What is Bot Hunter? That it detects any malicious activity by comparing it to the activities of authorized users. The activities of authorized users are kept as a format of log, and that log is maintained, and every time a new user comes into it, it is compared to the log of the existing users. So Bot Hunter, if he finds that there's the activity that of the new user is very much different from the activities of the user log, then it shuts that user down. Instead of asking for permission of any operator or anything, it just shuts the user down. It just take away the access, or based on the settings it can also ask for changing the access or re-verifying your authentication. So that is Bot Hunter. The second ASN system that we will see is Bot Sniffer. So Bot Hunter was an active IDS that exists, and Bot Sniffer is a passive IDS. So it performs basically the same task that Bot Hunter does, but here, instead of denying the access or instead of directly asking for the authorization, it sends the unusual log report to a operator which is already there, who is available. Intends the operator checks the uses of that user or that system, and based on the uses and based on the verification, he decides whether that user is an authorized user or an unauthorized user. So after the verification, the operator that is sitting there, he has the option of either disabling that user or system or letting him continue the work that he is doing. So again, if you use Bot Sniffer, it does not provide real-time security. Like, you require a certain lag period, certain time for the operator to see, compare, and then decide. But it provides you the filtering, and it provides you with the safety that you are not disabling like right user if they're doing some activity which is not exactly matching with the log. So both has their advantages and disadvantages. The third system that we'll be seeing is attack graph. So what is attack graph? The users who are logging into the system, their activities, their time periods, their data, whatever amount of data they are using is mapped. It is plotted in the form of a graph. So that graph which is plotted is compared, and like with every user entry that is made. So if a user enters into the system and the access graph that is plotted by his access to the system is going away from the user, from the user log, so we can see then that tells us that the user is not actually following the pattern that other users have followed who has logged in before him. So it again creates a possibility of unauthorized access. So this comparison, this attack graph comparison, can be used to check whether the user is authorized or not by comparing his activities with the users whose graph is already plotted or who has been already logged into the system. These three existing systems basically checks for the activities, which is the new users activities, and compare it with the activities of older users. What they lack is proper countermeasures. So, and for example, if you say that cloud cloud is the most happening thing right now. So if a user is not actually intruding into the cloud system, if he's installing a VM, a layer of malicious software inside the VM, for example, before the installation of the VM, the OS has a malicious software installed in it, then the VM will always feel that all the things that OS is doing is authorized only. So it will not be able to differentiate between authorized access and unauthorized access. So what NICE provides is a framework for cancelling all layers, for selecting proper countermeasures to all the type of intrusions. So in the next section we will be dealing with NICE framework. So now we are going to see the models of NICE. There are different models that is used for the NICE framework. So we are going to see all the three frameworks, all the three models which are available. So the first one is threat model. This protection model focuses on virtual network based attack detection and reconfiguration solutions to improve resiliency to zombie exploration. The proposed solution can be deployed in infrastructure as a service, that's IaaS, cloud networking system. Cloud services users are free to install whatever operating systems or applicants they want, even if such actions may introduce vulnerabilities to their controlled VMs. So this threat model introduces the protection for those type of cloud models. The second model that we're seeing here is the attack graph model. An attack graph is a modeling tool to illustrate all possible multi-stage, multi-host attack paths that are crucial to understand threats and then to decide appropriate countermeasures. In an attack graph, each node represents either precondition or consequence of an exploit. Attack graph is generally helpful in identifying potential threats, possible attacks, and known vulnerabilities in the cloud system. If an event is recognized as potential attack, special specific measurements or countermeasures can be applied to mitigate its impact or take actions to prevent it from contaminating the cloud system. This provides a sense of security to people who are using the cloud model. The third form of attack, which is the most common form of attack, is the VM protection model. So, the VM protection model of NICE consists of a VM profiler, a security indexer, and a state monitor. Security index is specified for all the VMs in the network based on various factors like connectivity, the number of vulnerabilities present, and the impact scores. So what are impact scores? Every vulnerability that is present is assigned an impact score based on the type of impact that they have done on the system and they might do on the system. So this impact score decides that which threat should be given more privilege towards other. Like if you have a series of threats, then those impact scores, based on those impact scores, you can decide that which of them should be treated first, second, and so on. There are 4 states of a VM, which are stable, vulnerable, exploited, and zombie. So what is stable state? The stable states is where there doesn't exist any known vulnerability, so it's called stable. The vulnerable stage is the presence of one or more vulnerabilities where uh, in a VM which remains unexploited. So you you know that there's a presence of the vulnerability, but you still have not exploited like which area or exactly what the vulnerability is. Exploited. The third stage is exploited state. At least one of the vulnerabilities has been exploited and the VM is compromised. So one of the vulnerabilities has been attacked by an attacker and has been compromised. So the system has been taken. So immediate measures should be taken in that perspective. And the zombie. The zombie is where the VM is under the entire control of an attacker. So basically not a single system, not a single network, not a single device, but the entire system is under the control of the attacker. That is the most serious form of attack. That is zombie mode, because in turns it attacks all the connected networks, all the connected devices, and all the connected users. So if an attacker gains zombie access on your system, the then you have to either shut down your system or just take the most immediate countermeasures. Otherwise, he can damage, delete all your data and create a lot of hazards to you. So now we'll see the system design and the framework of NICE. So the next diagram that I'll show you guys will show the entire system design. Yeah. So this is the architecture of a NICE, which is there inside one cloud server cluster. So the major parts that we can see are NICE A, the VM profiler, the network controller, and the attack analyzer. So first we'll discuss about these major components of this framework. The NICE A is a network-based intrusion detection system, which is NIDS agent installed in either DOM-O or DOM-U in each cloud server. It scans the traffic going through Linux bridges that control all the traffic among VMs and in out from the uh, physical cloud servers. Here, Snort is used to implement NICE A. It will sniff a mirroring part on the each virtual bridge of the open V switch, that is also known as OVS. Each bridge forms an isolated subnet in the virtual network and connects to all the related VMs. The alert detection technique that is used in NICE A depends on the implementation of NICE A, which is again using Snort. So the individual alert detection false alarm rate does not change. However, the false alarm rate could be reduced through the architecture design. So this NICE A is the major component that exists in the framework of NICE. The other things that are there includes of VM profiling server. So virtual machines in the cloud can be profiled to get precise information about their stage, services running, open ports, and so on. Any VM that is connected to more number of machines is more crucial than the one connected to a fewer VMs, because of the effect of compromise of highly connected VMs can cause more damage. For example, if many of the systems are combined together and that entire system fails, then it results in a huge problem. It results in a larger problem, a problem of larger aspect than the failure of a single VM. So, VM profiles are maintained in a database and contain comprehensive information about vulnerabilities, alert, and traffic. The data comes from basically three locations. The first is the attack graph generator. So, the attack graph generator generates an attack graph and it provides as a feeding data to the profiling server. The second place from where the data is generated is the nice A, and it is also generated from the traffic patterns. The third major component in the nice framework is the attack analyzer. You can see it here. So attack analyzer is the the part of the framework which actually analyzes the attack and generates an attack graph. So the process of constructing and utilizing this attack graphs consists of information gathering, attack graph construction, modification of attack graph, and various other strategies which result in preparation of a complete attack module, which can be analyzed later to define the correct user and the correct user usages. Then the exploit of the path analysis. What is that? The each node of the attack graph represents a malicious behavior. So the path from one behavior to another is known as the path between the attack graphs. So this information is used for modeling the attack graph with the SAG. Each node of an attack graph represents an exploit or an attack or an attempt of an exploit by an attacker. The fourth major component of the framework is the network controller. So this network controller is a key component to support the programmable network capability to realize the virtual network reconfiguration feature based on an open flow protocol. It is also responsible for collecting network information of current open flow network and provides input to the attack analyzer to construct attack graphs. Through the cloud internal discovery modules that use DNS, DHCP, LLDP, and flow initiations, network controller is able to discover the network connectivity information from the OVS and OFS. This information includes current data paths on each switch and detailed flow information associated with these paths, such as TCP/IP, MAC, and other addresses. The network flow of topology change information will be automatically sent to the controller and then delivered to the attack analyzer to reconstruct attack graphs. All of these, the network controller, the VM profiler, the attack analyzer, and the NICE, they're all combined together, and this entire thing is called the control center. This control center controls the entire cloud server cluster IDS. So the whole cloud input and output of the data is controlled through this control center. So these four components consist of the NICE framework. Countermeasure selection. The major difference between all the existing technologies and the new technology, that is NICE, is the countermeasure selection. So what is countermeasure selection? So when vulnerabilities or some kind of unprecedented behavior are identified as suspicious, several countermeasures can be taken to restrict attackers' capabilities. And it is important to differentiate between compromised and suspicious VMs. So, the compromised VMs are the VMs which are completely taken or which is under control of the attacker. And the suspected VMs are which might or might not have some vulnerabilities. So it's very important to differentiate between both of them. The countermeasure serves two purposes. First is protecting the target VMs from being compromised. And if at all a VM is compromised, then its identification. So first it tries to protect it from being compromised, and if it is compromised, then it identifies that it is compromised. How does it do it? It does so by maintaining a security measurement matrix, which has all the data related to the security and the amount of access that is given. Whenever a user, precedented or unprecedented, tries to gain more access or tries to exceed their access limits, then it is entered into this matrix, and based on the analysis of this matrix, it is decided that whether a system is compromised or it is still under doubt or suspicious. So there are few mitigation strategies, which are cost, intrusiveness, condition, and effectiveness. So cost is the unit that describes the expenses required to apply the countermeasures in terms of resources and operational complexity, and it is defined in a range from 1 to 5, and higher metric means higher cost, that is 5 being the highest. Intrusiveness. Intrusiveness is the negative effect that a countermeasure brings to the SLA, and the value of intrusiveness is 0 if the countermeasure has no impact of the SLA. This condition, that is the condition, is a requirement for the corresponding countermeasures. Effectiveness is the percentage of probability changes of the node for which the countermeasure is applied. So the effectiveness also measures the actual impact that this migration strategy is having on the network. So these are the strategies which is used for countermeasure selection. Now I'll be moving on to the conclusion. So it is, as you have seen, this NICE is used to detect and mitigate collaborative attacks in the cloud virtual networking environment. It utilizes the attack graph model to conduct attack detection and prediction. The proposed solution investigates how the programmability of the software switches based solution to improve the detection accuracy and defeat victim exploitation phases of collaborative attacks. There are many advantages of this system, which includes that NICE significantly advances the current network IDS solution by using programmable virtual networking approach that allows the system to construct a dynamic reconfigurable IDS. NICE, a new multi-phase distributed network intrusion detection system in a virtual networking environment that captures and inspects suspicious iCloud traffic without interrupting users, applicants, and closed services. It also incorporates software switching between VM exploitation attack without interrupting existing normal cloud services. And it is used to investigate the zombie explorative attacks. The system performance evaluation demonstrates the feasibility of NICE and shows that the proposed solution can significantly reduce the risk of cloud system from being exploited and abused by internal and external attackers. So basically, this NICE technology is the next step in the network intrusion detection systems, because it includes not only the detection part but also what if it is detected, how to prevent it, and if not able to prevent it, what if it is detected. That is the countermeasure part. And after this, in the future, in the time that's coming, almost all of the networks are moving towards NICE. Currently also many websites have started using NICE technology, countermeasure selections, in one form or another, not exactly the NICE architecture, but everyone has started using the countermeasures thing. Many websites like Flipkart, Amazon are using countermeasures security measurements for their for the safety of their websites. And the VM profiling, like all of the VM servers, comes with a profiler that not only doesn't let anyone to use the VM for malicious activities, but also it sees that where the VM is installing, that OS is not a malicious OS and it is being installed in a proper host OS. So we have seen the conclusion of the nice structure. Now for the value addition to your course, you can also take up few quizzes. So depending on all the different sections, I have prepared quizzes. So basically there were 5 sections: introduction, existing systems, the framework, the technology, and the countermeasure. So based on that, I have 5 quizzes made for you. So these are the links to the quizzes. These links will be provided in the description below. So I'll show you the quizzes. The quizzes are all made upon paulmaker.com. You can go there and access the quizzes and take the quiz up. So accordingly, all the questions are there. You can select the question numbers, and once you select the options, you can do next. It will be automatically saved, and the scores will pop up once you have submitted all the questions. So these are the links of all the quizzes. These links will be available in the description below. So thank you for watching the Camtasia tutorial video. This video is made upon the tool the tool called Camtasia, and basically I have tried to cover all the dimensions of NICE, the future scope of NICE, the current status, the current existing technologies, and how NICE is different from it. And thanks for watching.